Good afternoon, and welcome to the webinar. My name is Kurt Smith with Applied Pavement Technology, and I'll be serving as your host for today's webinar on sustainable design approaches. This is part of an ongoing series of webinars on sustainability that were developed under the FHWA Sustainable Pavements program and covers all stages of the pavement lifecycle. Before we get started today, I want to mention just a few housekeeping items. First of all, this webinar is scheduled for a total of 1 hour and will consist of a 45-minute formal presentation and a 15-minute question and answer session. The questions will be answered at the end of the formal presentation, but you may submit your questions at any time during the presentation using the questions box on your control panel. If you don't see the questions box, you may need to click on the orange arrow icon on the control panel to display the settings. At the end of the session, we will work to answer as many of those questions as we can within the time allotted. For those questions that we do not get to, the panelists will prepare and post responses to all attendees, and we will notify you when those become available. At the conclusion of the webinar, a copy of the presentation will be shared with all registrants via email, along with a link to the webinar recording once it is processed. You may need to regularly monitor your spam or junk folders, as we are discovering that some of our webinar communication for the registrants occasionally gets redirected there. With that, I would now like to introduce Monica Urato with FHWA, who will provide a quick look at FHWA's Sustainable Pavements program.
Okay. Good afternoon. Our speakers for today will be Khadija Ngozi Bullock and Tom Yu. This is a list of acronyms that we have that will be used throughout the presentation, so if there's something you need to come back and check, this is where you'll find it. I'll give you a little bit of background, a quick background on the Sustainable Pavements program, which began in 2010 with the vision and mission to advance the knowledge and practice designing and constructing and maintaining more sustainable pavements through stakeholder engagement, education, development of guidance and tools, which this series of presentations is a part of, and also the development of the the Federal Highway Administration Sustainability Ambassadors Program, which is a group of FHWA employees from different disciplines, which main goal is to expand the knowledge and outreach within their field that complements the Sustainable Pavements program. With that, our sustainability ambassadors will be presenting a series of webinars. This is the third of the series of 10 webinars. For each webinar, you will receive 1 professional development hour, and if you complete 8 out of the 10 webinars, you will receive a course completion certificate. What you should be expecting to learn today from this presentation will be what design considerations are related to pavement sustainability, what general and specific design strategies are available for improving the sustainability of asphalt and concrete pavements, and what are some future directions and emerging trends. From the Sustainable Pavements program, the first thing that we developed was a definition, and this is on why should we focus on sustainability. And the goal of our definition of our sustainable pavements definition is achieving the engineering goals by preserving and ideally restoring surrounding ecosystems, the use of financial, human, and environmental resources wisely, and meet the basic human needs such as health, safety, equity, employment, comfort, and happiness. With that, the benefits of being more sustainable, we're focusing on the triple bottom line, which includes not only the economic benefits, but also looking into the environmental and social benefits. There are opportunities for improving sustainability throughout the pavement life cycle, and today's webinar focuses on the design aspect of the pavement life cycle. Sorry about that, I got ahead of myself. And with that, I will turn it over now to Khadija Ngozi Bullock, who will be presenting about the design considerations for pavement sustainability.
Thank you, Monica. I'm going to talk a little bit about some design considerations related to pavement, and then I'm going to go into some general strategies for improving pavement sustainability, and then I'm going to apply some of those strategies specifically to asphalt pavement. This slide here shows several factors that affect pavement design. And the first few we're probably all pretty familiar with. We're all concerned with the performance life when we design pavement, and we're at least concerned with the initial smoothness or friction of that surface during our pavement design. But I'd like you to also take a look at the other aspects or other design aspects, such as reducing noise or splash spray, or reducing urban island effect or local thermal environment. These attributes all have an environmental, social, or economical impact, or they have a sustainability impact, and we can use these areas to reduce our impacts overall or have a higher sustainable pavement. So if we take a look at sustainability in our pavement designs, we should be looking at the entire life cycle of the pavement. Now, usually as a pavement designer, I am concerned with getting a low initial construction cost. But if our agencies would really take a look at targeting a low overall life cycle cost while taking a look at really good pavement materials and really good construction practices, and reducing traffic delays and reducing fatalities in work zones, we will come up with a very good product. Now, if we look at the use of that pavement and think about sustainability impacts, if we think about not only applying a smoothness criteria during the initial pavement, but throughout the life of the pavement, we will have a more sustainable pavement. We know that rough surface will have higher fuel consumption and particularly higher emissions. So a smoother surface would reduce that while also potentially reducing safety concerns. A longer life pavement generally means initial higher costs, but for the life cycle of that pavement, there would be reduced costs. And we should also take a look at not only the initial construction, but how we will be rehabilitating that pavement over its life cycle. And then at the end of that life cycle, what will happen to that material? Talking a little bit about some of the design aids that we can use for a more sustainable pavement system. This slide here talks about ME design. Now, I know all of us are using various methods for our pavement designs, whether they be a state or local table using state or local mix, or perhaps you're using the 1993 AASHTO Pavement Design Guide, or perhaps you're using the new ME design. Some of the particular aspects of design that we should incorporate for a more sustainable pavement is to consider the entire life cycle of the pavement, to consider your construction techniques, to have a better way to identify pavement distress or the time that it will take to achieve a level of pavement distress, and to be able to incorporate different types of materials will help you in providing a more sustainable design. And this will really help you to kind of minimize some of the pavement thicknesses, reducing material costs, and some other things that we'll talk about further in these slides. In addition to a high-quality pavement design aid, we also need to look at design aids for life cycle costs analysis so that we can incorporate costs of the rehabilitation and preventative maintenance that the pavement will need during its life cycle. We should also be looking at environmental aspects, and a life cycle assessment can help us in kind of taking a look at the environmental impacts of our pavement design. As well, we should be taking a look at how we would be improving sustainability and applying some sort of rating or metric for that so that we can track our progress and that we can compare projects. All of these sources, the Sustainable Pavement Program has references on their website, and we will give you a link to that website at the end of this presentation. Let me talk a little bit about some general strategies for improving pavement sustainability. The first I've already mentioned, that's achieving a longer life, and this is the longer life of the entire pavement. And I talked a little bit about doing that with a high-quality pavement design tool, as well as using high-quality materials and high-quality construction techniques. In doing so, we will ultimately spend less money over the life of the pavement. If we reduce our pavement thickness, we will be reducing the materials used in the pavement system, which will ultimately reduce not only economic or costs, but will contribute to a less of an impact to the environment. And using high quality design tools can help us to do that. We want to consider using a higher pavement structure in areas that require it, where we have high traffic lanes. And so consider if you've got areas where you know you're going to be having higher traffic, or maybe you've got high occupancy lanes or truck lanes, consider maybe only doing deep or significant pavement sections in that area as opposed to applying that pavement section over your entire roadway. Or, in another aspect, consider rehabilitation of your shoulders in a less stringent time frame than the rest of your roadway. This again reduces materials. We don't always consider this, but reducing noise is certainly a societal impact, especially in urban areas or residential areas. This is often done with the use of open graded aggregate in your surface asphalt mix. Sometimes you can also achieve a quieter noise ride with well-textured concrete. Again, we'll talk about achieving and maintaining smoothness in our roadway as a way to improve sustainability. This helps us to reduce fuel costs as well as emission costs. Not only do we want to maximize the use of recycled materials, but also local materials. Our bottom line should be in reducing the amount of transportation of materials brought into the site. This reduces a lot of impacts to our environment. But we should also consider, if we have the opportunity to use local virgin materials, we should do so, because it does also help the social, economical, local aspects of the area. And again, it also reduces the amount of material that we're trucking into the site. We don't always have control over utilities, but if at all possible, we should be coordinating with utility companies during the pavement design so that we have less impacts to those utilities during construction. This means that if there's going to be some sort of utility repair, that we try and get that done before we construct our new pavement so that we don't have those fresh cuts coming in shortly after construction. And in a more innovative approach, We should also try and address stormwater runoff issues, if at all possible, with our pavement designs. Now, this isn't something that we can do everywhere, and it's certainly something that we should limit to very localized areas, but I will talk a little bit more about that in this next session or section, where I will talk about how we can apply some of these specific design strategies to asphalt surface pavement. So this slide shows some typical pavement structures for asphalt. A lot of us are probably building asphalt pavement structures that are similar to this. The conventional asphalt pavement here you see has multiple granular base layers. This is an excellent area, particularly your granular subbase layer, to use recycled materials such as milled asphalt. Looking at your full depth asphalt pavement section on your left, where we often use higher quality asphalt in the surface materials, you can use recycled asphalt materials in your asphalt base layers. Again, both of these pavement structures could benefit from minimized pavement thicknesses with a high quality pavement design. When you're faced with local virgin material that is not quite suitable for the traffic loading that it needs to support, keep in mind that some sort of stabilizer, such as cement, can be used in these situations as opposed to trucking in higher quality granular material. In addition to that, the inverted pavement section here is a good way to rehab poor pavement systems. So for example, if you've got highly fractured asphalt material and you need to rehabilitate a roadway, you can break up that asphalt and cement it and use it as a cement-bound subbase layer and build on top of that with new material. So a good use of both virgin and recycled material in your design. Composite pavements are a great way to use an inlay truck lane. If you've got a lane that you know is going to receive high traffic and you need to have a higher or more sturdy pavement structure, you can make use of a composite or semi-rigid pavement type, knowing that you can bridge your surface layer with asphalt with the overall roadway. Again, this is another way to treat or rehabilitate roadways as well, particularly if you've got a concrete roadway and you need to rehabilitate it with a lower cost material such as asphalt. Speaking of overlays, as I've done on most of these slides, here again is a slide reminding us that overlays for asphalt pavements is a great way to rehabilitate your pavement and extend the life of your pavement. Again, we want to make sure that we want to reduce the amount of material that we use in the overall pavement life, but we want to use that material widely to make sure that we can extend the life of that pavement as much as possible. I've talked a lot about the surface of your asphalt pavement, and in order to get a high quality surface material that lasts a significant amount of time, we want to make sure that we're using the right type of material for the job. So this means if you've got a site that would most benefit from a high friction material, you're using material for that reason. If you've got noise reduction or splash spray reduction in mind, that you're making good use of your open graded asphalt material in those areas. So again, just using the right type of material for the job. And that also includes your preservation materials. And we will be having a webinar that will discuss that topic in more detail. To go back to the item of the porous asphalt pavement to help out in some of our areas where we've got a lot of stormwater runoff that we need to mitigate, I wanted to kind of give you an idea of what that pavement structure would look like, but I also wanted to caution you that these aren't typical pavement materials. The granular material used in this pavement section is used in order to allow water to infiltrate and to clean or cleanse that water as it infiltrates through the pavement system. So this is a clean aggregate. As well, this type of system needs to be designed for a specific type of water storage capacity. So you'll probably want to bring your hydraulic engineers into this type of pavement design. Napa and some others have some design aids to assist you with this. It's very good in low traffic areas, particularly in parking areas or shoulders and trails. But if you've got an area that often gets inundated with water and you don't have area off of the side of the road in order to capture and treat that water, this is a creative way for you to deal with that type of issue. And then another innovative concept, and I've kind of touched upon this, is the perpetual pavement. A more sustainable pavement is a pavement that has a sustained life cycle. And the idea of designing a pavement that has high quality layers to withhold the traffic load that's going to last for an extended amount of time, with the idea that you're going to replace the wearing surface with frequent rehabilitation projects, is the ideal pavement design for higher or improved sustainability. So when you're looking at pavement designs, really you want to stress looking at the entire life cycle of the pavement while also looking at what it's going to cost or what the materials are going to be used for rehabbing that pavement, and how you can reduce impacts to the overall environment and the society while doing these things. So with that, I'm going to let my colleague talk about how you can apply these design strategies to asphalt pavement. Tom is a pavement design program manager in the Office of Infrastructure at Federal Highway Headquarters in Washington, D.C., and he's going to go ahead and talk about concrete pavement. Tom?
Thank you, Khadija. Yes, I'm going to be talking about sustainability for concrete pavements. And before I get started, I just want to point out that both Khadija and I are not people working on sustainability per se, but we are what we call sustainability ambassadors, and these are people who are invited to participate in sustainability program to become better aware of what sustainability is all about and see how sustainability applies to what we do and spread the good word. And what I come to realize is that sustainability is not something that we do separately from what we normally do, but more and more is becoming a necessity because, for example, for concrete pavements, in many places the availability of good aggregate is becoming more scarce. So dealing with that is becoming a necessity, and things like fly ash, for example, supply of fly ash is becoming more scarce. So how we deal with that is becoming a necessity. So the sustainability. So in some ways we need to find sustainable solutions to do what we need to do. So sustainability is something that we may have to look to find solutions to the things that we need to do. Okay. So for concrete pavement, first of all, the primary benefit of concrete pavement is its long life. There are many different types of concrete pavements, but today primarily what we have are jointed plain concrete pavements and continuously reinforced concrete pavements. And the way we go about selecting pavement type, it depends on depends on many things, primarily cost, but we could also consider sustainability as one of those criteria. Um, in places where we have the access is very difficult, in heavy urban areas, for example, we might look for a very long life solution like CRCP, so that we don't need to disturb the public so often. So concrete pavement oftentimes might be considered a slightly higher cost option, but again, it's long life it is the benefit we get to offset that higher initial cost. So composite pavement for concrete pavement for two-lip paving is something that we can consider when we if we have issues with availability of quality aggregates, or if we want to utilize recycled material, we could consider using the recycled or lower quality material in the lower lift and more durable material in the surface layer. So this is one way a sustainability solution will help us build a quality concrete pavements. The overlays, we have various options for overlays, but really for concrete pavements, we have what we should consider is that really the best time to consider the preservation of concrete pavement is right up front at the design stage, so that we build a pavement that doesn't require a lot of maintenance or uh, that doesn't deteriorate, so we don't have to deal with distresses over the life of that pavement. So by the time we have to do overlays, in some ways we're fighting a losing battle, but then we do have a large network of pavements that we could use the overlay option to preserve. And asphalt overlay can be a very effective solution to extend the life of existing concrete pavement. By placing relatively thin asphalt on top, it greatly reduces the stresses that the concrete pavement feels. So we can greatly extend the life of that pavement. But what we have to be careful is that the condition of the underlying pavement. If we have a lot of distresses in the underlying pavement, that'll reflect right through. So that's one of the things that we have to consider if we're thinking about doing an overlay. Bonded concrete overlay is also possible, but that needs to be done with extreme care because bonding a fresh concrete to an existing concrete is there's a lot of art to doing this. And it is absolutely critical that the two layers stay bonded together for the solution to work. So for the most part, it's probably a feasible solution if you have an existing CRCP. But if you have a jointed or long paneled concrete, like a jointed plain concrete pavements, bondage is probably a higher risk solution. In those cases, you might be better off just doing an asphalt overlay. There are various surface texturing options for concrete pavement, and of course, the surface is what traveling public is most sensitive to. We want smooth and safe surface, so there are various options of creating that surface. Most often, we do some sort of turf drag and pining in the U.S. In Europe, they tend to favor exposed aggregate. Um, and either types of textures are workable. But if you have an existing pavement that require a new texture, we have different options. We can do diamond grinding, or we can do grooving, or we can do grinding and grooving to keep that texture stay longer. Um, Concrete pavement, concrete option is also available for stormwater management. I don't particularly favor doing this because, as you all know, water is like the worst enemy to pavement. So for me, mixing water and pavement doesn't really make sense. But if you have issues with stormwater management, this is a possible solution, and there is a concrete solution for that. So again, the biggest benefit of concrete pavement is long life concrete pavement, and ideally we ought to build pavements to last as long as the material lasts. So we typically we tend to think of pavement with something that has a design life, and we tend to think that at the end of the design life, if the pavement is still in good condition, we think we're over designing. But the reality is, once we put the pavement out there, we have to keep that forever. So the easiest way to maintain that pavement is actually for that pavement not to develop these stresses at all. So what we really should be doing for sustainable solution really, because if you only have to build the pavement once instead of twice or three times, the sustainability benefit is obvious. We'll say there's a tremendous cost savings as well as social impact savings and environmental savings. So long life solution is something that we should definitely look into. And we think of 40 years, 50 years as a long time, but we shouldn't really think about any specific design life in mind. We should just build a pavement to last, like the Romans have done. So in doing that, then pavement foundation becomes also important. In current design procedures, we don't pay a lot of attention to foundation because uh, aggregate base or subgrade really don't impact the pavement response of concrete pavements very much. So we don't tend to think it's very important. But the reality is, if we have contaminated base, if we have water problems in the base, subgrade, that pavement will not last long time. So it is extremely important for the longevity of that pavement to have good foundation, and this is one of our focus areas at Federal Highway. So, and there's also a lot of very good information about recycling. We can we can use recycled concrete for in many different applications, including base materials, fill materials, as well as recycling aggregate right back into new concrete. And there's a lot of very good publications in National Concrete Pavement Technology Center, the CP Tech Center at Iowa State. They have a whole website dedicated to recycled aggregate. So, what are the future directions and emerging trends in pavement design? It's actually mostly the things that we discussed today. Uh, we need to think about performance cost as well as environmental and social costs, not just for sustainability in itself, but out of necessity. Again, the uh, the the materials like aggregates, fly ash, are becoming more scarce. So we need to find sensible solution. That means designing pavement to perform better. So performance-related construction specifications and materials are become more important. So those are becoming part of our whole pavement strategy. Designing pavement to last, building designing materials to last, and ensuring that we have the construction quality so that uh, the, the pavement constructed will perform as intended. And using new materials such as recycled materials and new binders. New binders might refer to things in asphalt or in concrete pavements, supplementary cementitious materials. We can use different design strategies to deal with urban heat island effects, and we can consider future rehab, preservation things factors at the design stage. So we design pavement to last, and not so much designing to thinking that there's a design life and constantly having to deal with distresses all the time and repairs and rehabilitation. So that's all I have on concrete pavement part. So I'll turn over to Monica for summary.
Okay, with that, I will wrap up the presentation with some of the key takeaways. So from this presentation, you're able to set goals for sustainable design practices, consider multiple design alternatives, use the life cycle approach, think about the technical areas to consider, such as pavement structure optimization, aggregate sourcing, specifications, and the transportation of the aggregate, and other sustainable mixes such as warm mix asphalt, and the construction quality standards such as smoothness, compaction. And with that, we also have other products from our Sustainable Pavements program, such as the Guide towards Sustainable Pavement Systems. And we also have a life cycle assessment framework. We have other tech briefs and our previous webinar series, and all this along with the roadmap, and all these could be found in our Sustainable Pavements program website. To learn more about sustainability throughout the pavement life cycle, please join us on our next webinar, which is Sustainable Pavements Construction, which would be held January 30th, same time. And for more information, please visit us at our Sustainable Pavements website, or please feel free to contact Heather Jello or myself, Monica Jurado. And with that, I'll pass it over to Kirk and open it up for questions.
All right. Thank you, Monica, and thank you to our speakers this afternoon. We appreciate taking the time to walk through and share some of their information with everyone today. We are well in advance of our time here, so we do have time to entertain some questions, and I would encourage you to use the questions box on your control panel and submit those questions, and we'll try to get through as many as we can in the remaining time here today. We've started to get some, so I'm going to start kind of going through that list. I think maybe we'll first start with a question. I'm going to direct this one to Heather. Heather Dilla is with us. She's with the FHWA, and she's actually overseeing the FHWA Sustainable Pavements program. There was a question, Heather, if there is a difference between porous or permeable pavements, and also where those potentially could be used.
This is a great question. In general, permeable pavements, to me, is the overarching name. And then you have porous asphalt, and then typically they call it permeable concrete, or pervious concrete, sorry. So I think of permeable pavements as just a category of all the different types, and then there's also pavers as well, permeable pavers. But they all do the same thing for those particular types of pavements. The key is that they're full depth porous pavements. And so when it doesn't matter whether you call it permeable asphalt or porous asphalt, people can use them interchangeably, but typically it's called porous asphalt and pervious concrete. That's what you would see but in literature. So just to know that when you're looking. There are other porous surface applications that are different, and they don't have that full filtration process and that storage basin that would really hold the stormwater if you're getting a big storm. They are more commonly used in the U.S. Than I would say the full depth porous pavements, and they're very commonly used in the Netherlands. And those treatments are called open graded friction courses. And so it's just a porous surface layer that's often used for spray splash issues. Also, if you combine it with ground tire rubber, you can also reduce some of the noise that may occur. So the difference that's the main difference in the porous pavement category because that it's open graded friction course are different than the porous pavements, but I don't think they're full depth porous pavements, and you need to be clear to see it to make sure it's a full depth system, because in Europe, for example, they'll call those open graded friction course or those surface treatments, they often call them porous pavements. So there's a lot of confusion about the words, and so it's always good to double check the surface, or not the surface, the cross-section of it to see what type of design they're actually talking about, just to be aware. But a full depth gives you, again, the filtration of storms. It cleans up the pollutants, can hold the storm water, and can reduce the need for various stormwater collection treatments that you may need. So that would be my answer. Hopefully I clarified that.
All right, very good. No, I think that is a common question too, so I think that it's good to get that clarification. Let's move on. Next question is for Khadija. Khadija, in your discussion about noise levels, there's a question about there's a concern with using certain pavement treatments as those might tend to increase noise levels. So is there a way that we can try to control the noise emissions that might be associated with different types of treatments on asphalt pavements?
Yes. So I'm not quite sure what we mean by pavement treatments. If that's like preventative maintenance type treatments. If you're looking at surface treatments like chip seals, I know that they're a quick and low cost solution for increasing the service life of your pavement, but they can be very noisy. I know that there are some alternatives to things such as chip seals. I know that with the polymers that we're using, thin asphalt overlays, and these are, it's an asphalt product that is applied typically less than an inch. It is a great alternative, and it's not as noisy as a chip seal is. You can also maybe reduce the noise of a chip seal by applying a chip seal and then applying a sealant on top of that, such as a fog seal. So there are options that you can use to try and reduce some of the noise, or there are alternative surface treatments that can be used. And I believe that we've got a webinar, a maintenance and preservation treatment webinar coming up that will talk a lot more about a lot of those treatments, and will hopefully provide some pros and cons on the use of those.
All right, very good. Thank you, Khadija. Want to move it over to Tom Yu now. And Tom, there's a question whether we could explain the difference between a continuously reinforced concrete pavement and a traditional rigid concrete pavement.
Okay, I like this one. Okay, continuously reinforced concrete pavement doesn't have any joints. We put joints in conventional concrete pavement because concrete shrinks, and if you don't saw joints, they'll crack. So the joints are controlled cracks in effect. And so we've come to using about 15-foot joint spacing as a standard. And at those joints, we typically have dowel bars to make sure that we don't get thumped every time we drive over the joint, because over time we'll get a height difference at the joints if we don't have some sort of connection between the slabs. On continuously reinforced concrete pavement, what we do is we put a lot of steel to hold the cracks together. So the cracks are expected in continuously reinforced concrete pavement, but they're held together by putting a lot of steel together in the concrete pavement. So they tend to be a little more expensive, but they're probably one of the more durable types of pavements that we can build.
All right, thank you for the clarification. I'm going to go back to Heather. Heather, as a follow-up to your previous discussion on permeable and porous pavements, there was just a follow-up whether porous pavements are viable in freeze-thaw areas, or where salt and sand might be frequently applied to deal with icy type conditions.
That's a good question. So in freeze-thaw areas, yes, they are. The best source, I think, as far as on porous pavements in a cold application, cold weather, is University of New Hampshire. They have a stormwater research center where they do both porous asphalt and porous concrete, and they're measuring all of the pollutants that are filtered out through those systems, and they have a lot of other research on low impact designs for stormwater treatment in general, and they compare them all. So they are well versed in using porous pavements in that type of weather conditions. The thing that they have noticed is they've actually been able to put less de-icing salt on their porous systems, And that is largely because you don't have the melting of the snow or ice and then freezing again at night. You don't have that action because once it melts, it filters down into your porous pavements again, and you don't have that freeze thaw. So they've been actually able to put in less de-icing salts. The biggest thing is you cannot sand them. So it is definitely a change in how you maintain your pavements. You don't want to put sand in there because that can clog the pavements itself, the porous action. The other thing with porous pavements is you do want to maintain them. So there is a vacuuming process that they recommend twice a year to go and maintain so that the pores do not clog up. So there is that little bit of issue as well with porous pavements. So in areas that they do use sand as a de-icing agent, it's important to put signs. So I know that there was a porous job that I was out in Maryland here, and it was a parking lot, and they had to put up signs so that it says "Do not sand," to make it very clear that you don't want to put sand, and you will have to train those de-icing, the companies that are doing the de-icing and putting the de-icing products down, that they don't need to put as much down, and it can be. Once you put a little bit more, what they found in University of New Hampshire is if they put a little bit on, I think it was a third of what you would normally put down, it then becomes a mechanical process of just scraping it up, and then again the water filters through. So that is what I have found with regards to porous pavements in icy conditions.
All right, thank you. I now want to turn to Khadija and have a question for her. Khadija, there's a question about the use of perpetual pavements. You had a slide that showed that type of structure. The question is, are they currently used, or maybe how many states are currently use this, and does that have a significant increase in the cost of that type of pavement?
Yes, thank you. Thank you. That is a good question. I think the concept of perpetual pavements is not new. I think that if you take a look at a lot of our high volume, high speed roadways, you will see multiple layers in the pavement structure there. And I think that if you think about the idea of a perpetual pavement, being able to withstand load to the point where it does not show fatigue or distress, so it doesn't rut. So you're using high quality materials, which with the advance of a lot of the polymers and additives, we can do that. So this is really kind of an improvement on a theme that we've already been practicing for a while now. I'm not sure specifically where we are in the testing, the results of testing of this pavement. I'll kind of rely on my colleagues if they have any information to kind of chime in on specifics of if NARA or anyone else has specific testing results that they can speak about on the perpetual pavement. I know that initially the construction costs will be higher because you are using high quality material. A percentage of how much higher I couldn't give you, but ultimately the idea is maybe to spend more in the beginning, knowing that the costs to maintain that pavement will potentially be reduced over the life of that pavement, and then with the extended life, you have a higher potential to have an increased savings on this type of pavement system. So that's my general discussion, or to answer that question. And if I've got any colleagues that can add to that, feel free.
Yeah, that's fine. Heather, Monica, anything to add from your perspective on that?
I think it was a good answer. There's also information about perpetual pavements from the National Asphalt Pavement Association. They do put out stuff. They do a perpetual pavement award every year. we at the Sustainable Pavements program have a case study coming out on perpetual pavements that we will be releasing that does do the life cycle costs and give some of that analysis as well. But it's, again, just controlling, so you have just any bit of cracking, it's just at the surface and you don't get the base failure cracks. And so then therefore your maintenance is really simple and easy. So it's a great system to explore.
All right, very good. Let's move on. Next question is for Tom. Tom, there's a question. You'd mentioned the use of different types of recycled materials, and the question, pretty specific, if you're using AASHTO 93, is there any guidance on what kind of a layer coefficient to assign for some of the recycled types of materials, either a recycled asphalt aggregate or a recycled concrete aggregate? Any guidance or information on that?
Not that I'm aware of. I don't think the recycled materials would be too much different than virgin material in terms of layer coefficient. I don't know. Kurt, do you have any thoughts on that?
No, I think there's been some preliminary work I know that showed, I think, relatively the same, I believe. But, at the end of the day, the relative amount is generally going to be pretty small, so I don't think it's really going to have that significant an effect of the overall structural capacity of the pavement structure.
Right.
All right, let's move on. Got a question for Monica. Monica, there was a question about whether there's any or what tools are available to measure or compare sustainability in the pavement design process.
So in general, we do have a life cycle cost analysis tool, Real Cost, which is we're currently updating that, and we are also coming up with, through the Sustainable Pavements program, we have the life cycle assessment tool that's similar to Real Cost that should be coming up. And we also have the reference document that I talked about. Some of the first chapters, I think it's chapter 2, talks mainly about design and sustainability. And then we have the framework for an LCA, which also helps you set up your framework. And we have other technical briefs. Heather, is there anything that I'm missing?
Oh, you did a great job. And you have we're going to have a checklist that's going to go onto the website, but that's going to be more of a programmatic review and provide suggestions. So I think you should. But the main ones are the LCA tool that's coming out, and the in next year or so, and the LCCA Real Cost, which is already out.
And maybe, Heather, it might be a good opportunity right now to maybe distinguish between LCA and LCCA, just in case there may be any confusion between those two.
Yes, that's a good point. So when we use acronyms LCA and LCCA, it's easy to add another C in there, and we have noticed that people sometimes don't know the difference between the two. They're so commonly used. So life cycle cost analysis is assessing all the economic impacts of your pavement design. And that is typically done in most states for larger projects for the potentially determining different pavement types. And so we have a tech bulletin that goes through the process and gives some guidance on how to do a life cycle cost analysis. And we'll have 2 webinars that are devoted to life cycle cost analysis in this series. Then you have an environmental assessment as well. It is called life cycle assessment. So life cycle assessment evaluates and quantifies the environmental potential impacts of the product or the pavement design. And so in doing so, it's very similar to the life cycle cost analysis, where you're going to take instead of the costs of the initial construction and all the maintenance activities and the end of life activities, you're going to actually take in what materials are used, what energy is used, and resources are used, and then what are the resulting emissions. And once you get the resulting emissions, you can tie these to models to assess and give a potential environmental impact. And we'll have 2 webinars that go into the processes on how to do that such analysis.
All right, very good. I think that's important just to be able to distinguish between those two, because there has been some confusion, and I think it's important that people are aware that we are talking about 2 different types of analyses.
It's a great point, and many people will put take an environmental impact and add a cost to it, and so that's where it even muddies the water more. So you're absolutely correct, Kurt.
All right, thank you, Heather.
Oh, sorry. I just wanted to say all these tools will be found on the Sustainable Pavements website, which is listed right underneath the question mark.
Okay. Let's move back to Tom. Tom, there's a question: what is the normal service life of asphalt overlays on jointed concrete pavements?
I think that's quite variable because the life depends on the condition of the underlying pavement, but typically anywhere between maybe 10 to 15 years. But it could be as short as it could be shorter if you have poor condition underneath.
Right. Yeah. Particularly if you got poor load transfer at the joints, it's not uncommon, for those joints to reflect through the overlay very, very quickly and rapidly.
Right.
All right. Moving back to Khadija. Khadija, there's a question about the SMA, stone matrix asphalt, that you had in your presentation. Essentially, the question is, what are the benefits of SMA over other more conventional asphalt types of options?
Yes, this is a good question. SMA is great material. It's high durable material, so it tends to last longer than conventional asphalt. And with that extended service life, you still have good friction with this material. So I know that a lot of asphalt at some point, if it's not potholes or significant rutting or cracking, you have this polishing effect of the aggregate where your surface becomes smooth, and the SMA does not break down as quickly, and so you maintain that nice friction level on your surface. Also, SMA could be good for areas where you've got potential water on the roadway. It helps as the tires pass over the roadway to kind of channel that water away from the pavement. So it has that benefit as well.
Okay, and just back to Tom really quick, and I think this will probably be our last question. Tom, is there a recommended design procedure for any of these long life pavements, whether it's asphalt or concrete?
We do have some reports on long life concrete pavement, Federal Highway Administration reports. You can look through our library publications. And for long life asphalt pavements, perpetual pavement is definitely an option.
And I think specifically though, is there a recommended procedure? Does it have to be a mechanistic? Does it have to be an MEPDG, or can you use other design procedures?
It doesn't necessarily have to be MEPDG. And long life concrete pavement is more than just surface thickness. And unfortunately, that's primarily what design procedures focus on. Because design procedures, especially mechanistic design procedures, focus only on pavement response, so they don't fully account for the benefit of having good foundation. So we need to use good engineering, common sense, and good engineering to design pavements, in addition to using design procedures.
All right, very good. Well, we are pushing up against our time limit now, so I think we're going to cut things off right there. I do want to thank all of our panelists today for very interesting presentations and for addressing some of these questions. We will be posting answers to all the questions that were raised in today's webinar, and we will notify you once those become available. So with that, I want to thank you again for your time and your attention. We hope you found the webinar informative, and we look forward to having you attend our next webinar presentation, which is scheduled for January 30th. So thanks again, and best wishes for a happy holiday season.